Hi, I'm Adam. Welcome back to Godot Game Lab. In this one final episode, we'll add tooltips to the game. So if I buy a couple of units here and drag them into the battlefield, you'll see I get my traits activated. I can now right-click on items, for example. So if I right-click on this ring, you'll see that I have this nice little description, name, the icon, and what it does. And also the tooltips are kind of clamped to the game's screen. So if I right-click on this sword, you'll see that it won't go outside the screen, it stays within. Now, if I do any other action, like buying this robin, it immediately hides the tooltip. And also, I can go from tooltip to tooltip by right-clicking. So if I right-click on these gloves, and then right-click on the sword, with one click, it changes from one tooltip to another. Of course, I can click anywhere on the screen with the left mouse button as well to hide it. And I can also right-click on units. So if I right-click on a unit, I get this nice looking little tooltip with the tier, the name, health and mana bars, and item slots of the unit. So if I start equipping items like putting the gloves on Robin, putting the ring on Björn, drag them around, now I can actually see what items the units have equipped. And I have this nesty tooltip kind of thing. When I hover over the item, it also has the item description available just by hovering over it. Same thing with the other one. And one final place where we have longer tooltips is actually the trait bonuses to see what they do. So if I right-click on elf, it says that elves get 10%, 25% bonus attack speed. For the Viking, it has a longer description. It says when they fall below the HP threshold, they berserk. Pretty cool, huh? So if I buy some XP and go into a battle, you'll see that these values update live. So if I right-click on Björn now, I can see the mana generated by the attacks. I can see its health getting lower and lower and all that kind of good stuff. So for one last time, without further ado, let's get straight into it. Now let's start with the architecture first, like we usually do. Here the thing is, when I was making the reference project, I wanted to make this whole tooltip system to work with the built-in available Godot solutions, like the built-in window and pop-up system, but no matter how I tried to bend it to work as I expected it to, I couldn't. So the fault is probably on my end, and I could figure it out or ask for help and make it work somehow, but after spending many time on it, I figured it's just easier to implement my own solution for this, while making sure that it behaves exactly the way I want it to behave. And the thing is, this system is way more simple than what you can do with the built-in Godot solution. If you think about the whole window and pop-up system and games like Window Kill, you can do pretty crazy stuff with that. And I wanted something way simpler than that. So what I ended up with is this. We have two sort of specific or specialized tooltip kinds in the game. We have one that's called Detailed Tooltip, which is used by both items and trait descriptions. And we have one specifically made for units, displaying information about units. Now, both of these are constructed without a tooltip background and are instantiated inside a scene called GamePopup, which will be a panel container, so they have the same shared background for all kinds of tooltips. Since we can have two levels of nested pop-ups or tooltips in the game, these game pop-ups are managed by an auto-loaded class called TooltipHandler. Again, we could avoid using singletons or auto-loads in a game, but I feel like a tooltip system kind of justifies itself as an auto-load class, right? Like, there are many different parts or systems in the game which can trigger displaying a tooltip, and in this case, creating that coupling between the systems and the tooltip handler is a fair trade-off for the functionality you get. I want to emphasize this because, again, I don't want to demonize using singletons or auto-loads for your game. Sometimes it's just the easiest and best solution, right? So let me give you some in-game screenshots and examples of the use of these tooltips. So the game pop-up itself, as I said, is a panel container and it looks something like this. Now for the detailed tooltip, we can share the same thing for items and traits because they both have an icon, a title, and a detailed description with a smaller font. As you can see, there's no background for this because, again, they will be instantiated as a child under a pop-up. So they will have that panel behind them. Now, if we take a look at it in-game, it looks much better, right? So for example, an item description might look something like this. For the unit tooltip on its own, the scene looks like this. We have the tier of the unit, the name of the unit, we have the HP and the mana bars, this time with numbers. And also we have the item slots for displaying the currently equipped items. The unit tooltip looks like this in-game. And one final thing we might need to have is displaying simple messages like pop-ups, right? Timed messages. For example, if you want to buy a unit from the shop, sometimes you just can't buy a unit because your bench and the arena grid are both full. And if that happens, right now we only have a debug message in the console, but it's much better to display this kind of timed pop-up for the player to see that they can buy a unit now. And by default, GamePopups have a label attached to them as content if you don't want to instantiate some custom content like with the unit tooltip and the detailed tooltip. So GamePopups can be used on their own to display messages in a timed manner. Now that's about it for the architecture. Let's move on to implementation next. Okay, now I have my project open here, and the first thing we'll do is the game pop-up window. And just before we do that, we need to add an input action for displaying the tooltips, which in my case will be the right click on the mouse. So let's go to project settings, input map, click inside the add new action input field, and type in tooltip, press enter or click on the add button here, click on the plus sign next to tooltip, go under mouse buttons and right mouse button and click on OK. Now we have this new action. We can actually close this project settings window and let's do the game pop-up. So the root node for this scene will be another node, and let's search for panel container as the root node so we can design how this box or this pop-up windows will look like. And just before we do that, we can actually add all the nodes we need. Press Ctrl A or click on the plus sign here. Search for a margin container node. This will make sure that there's a nice little margin between the edges of our pop-up and the content inside it. And as we talked about in the architecture overview, optionally we want to have a label available. So for timed message pop-ups, we don't need to do any other customization. So with the margin container selected, press Ctrl A one more time or click on the plus sign here and add a new label node. Now let's rename a couple of things. So double click on the panel container and rename this to game pop-up. Double click on the margin container and rename it to something like content container. And if we were to ever refactor this scene, I just wanted to make sure that the content is always available. So let's right click on it and make it a scene unique name. So this way, if you move it around in the scene tree, it will be still accessible. Now we can set up everything, but before we do that, let's not forget to save this scene. So press Ctrl S to save it. And inside our project directory, let's go to scenes. And I'll just create a new folder by clicking on this button and call it Tooltips. So everything related to tooltips will be inside one folder, and gamepopup.tscn is perfectly fine. Click on save. Now let's select the pop-up and set up everything we need to make sure it looks nice. Let's go to theme overrides, styles, and create a new style box flat for this. And I'll make this a bit wider so you can see the properties a bit better. Let's click on the new resource. For the background color, I just click on this color here and I'll use a semi-transparent black color with 155. As the alpha, you can play around with these values and use whatever you like. Under border width, I'll add a 2 pixel wide border on each corner. And for the border color, I'll just use a straight up white color for the borders, like so. We can add a bit of a radius as well, so it's not that rectangular. I use a corner radius of 4 pixels on each side. And that's about it. That I think is a nice looking box, especially if we zoom out a bit, but we'll see how it looks inside our game in a sec. Now, one thing we also want to enable if we collapse this style box is under canvas item and visibility. We want this game pop-up to be a top level canvas item. So if we click on this, it will be enabled. And if we hover over it, it says that the canvas item will not inherit its transform from parent canvas items. It will draw on top of everything that doesn't have top level set to true. This is to make sure that this will be drawn over everything else inside the game. Now, it's not strictly needed to do this. If we use a singleton to manage all the pop-ups, we can also use canvas layers to provide a nice layering. It's just a quick and easy solution for this demo, but for your game, you need to make sure that, for example, if you have a tooltip active and you can pause the game, that the pause menu will be drawn on top of the tooltips actually. So when you use this setting, you need to be mindful that this will make it draw on top of everything else that's inside the game, right? But for now, that's a perfectly fine solution for us. One thing we can also do is we can select the content container, go to theme overrides and constants and set up a margin for all the sides inside this container. And on the sides, I use 6 pixels, and on top and bottom, I use 4 pixels. And you can immediately see the effect of this, right? So we have our content container here, which is a bit smaller because of the borders. And if we go to the label, you see that we have this nice border around our pop-up. And if we select the label, we can also do label settings if we want to have like a unique font or size or shadow for this text. But actually in this case, if we type in something, I'm happy with the theme default that we have set up. So if I put in some text like no available space to add the unit to, I'm happy with this text. And if you take a look at the ratio here, like if we have a message that is this long, it doesn't take up too much from our screen space if you take a look at these bluish purplish lines. So I'm actually quite happy with that. And I'll save the scene with Ctrl S. Now if we select the pop-up, we can reset its size. If we go to layout, transform and click on this button next to the size, it resets it. So this is what it looks like if we only have a label with a message, and I think that's perfectly fine. Now let's add some code to make it actually work inside our game. Click on the attach script button with the root node selected, and gamepopup.gd is perfectly fine. Click on create, and let's see what we need to do here. Okay, so this gamepopup is sort of the bread and butter of this whole system. So let's take a look at how we can implement it. First thing we do is we provide a custom class name called gamepopup. Then we'll grab an already variable reference to our content container so we can manage what content this pop-up is currently displaying. Now, inside the ready callback, just for testing purposes, we'll call the center method to make sure that our pop-up can actually center itself on the screen. But this is just for testing. What we actually want to do most of the times when this will work is to call a method called clear, which deletes all the children of the content container. So if we go back to 2D view for a sec, this label is only added for debugging purposes or design purposes to see what this pop-up looks like. But in-game, everything will come dynamically, right? So we don't need any children when the pop-ups are initialized inside our project. Also, we need to handle input events, right? So here we use input instead of unhandled input to make sure that this game pop-up can always pick up an input event when it occurs. But first we do a guarding if statement, because if this pop-up is currently not visible, then we don't need to pick up any inputs and handle them, so we can return immediately. But if it is visible, we need to hide the pop-up in 2 cases. Either we use the left mouse button to select something, or we started a dragging process or something like that. So when we left click and the tooltip is visible, I immediately want it to hide, right? But also, if we press the tooltip button again, which is the right mouse button, it means that we sort of toggled it, so we want to hide it in this case too. Now, of course, we are yet to implement that hide pop-up method, but that's what we want to do when either of these actions happen. Now, this clear method that we will call inside the ready when we are done with testing is pretty straightforward. We just iterate through all the children of the content container node and call queue_free on them to delete them, right? We'll also have a helper function called getPosition. Now this is super important because if you do design your tooltip systems from the ground up, there is a problem when you want to have a tooltip on either side of the screen, right? It might happen that the tooltip window is just too big and the tooltip would just overflow the screen size based on the mouse position. So you somehow need to grab a tooltip window and make sure that it's clamped within the screen space that we have, right? On all 4 edges. So what we do first, when we call this getPosition helper method, is we grab the current screen size based on the resolution that is set up, and we calculate the maximum position where this window can take space. And to get that, we take the screen sizes vector, right, the size vector, and subtract the size of this pop-up window from it. And this means that if we have, I don't know, a 1920 by 1080 pixel screen, and we have a 200 by 200 pop-up, then we subtract 200 from both coordinates to make sure that the top left corner of this pop-up is positioned in a way that the bottom right corner of the pop-up will still be inside the screen space. And to do that, we just use clamp I to clamp to integers and say that the final x and final y will be this. Like on both axes, we don't want to go into the negatives because that would mean that the pop-up is outside the screen space. The minimum value will always be 0 for both. And the maximum value will be based on this vector that we calculated, right? And when we're done with the calculations, we can just return a new vector to I with integers with the final x and final y values. Now, where do we use this helper method? We'll have a method called showPopup. And when we want to show any kind of pop-up, we need the content passed in, which will be for sure a control node, a UI-related node. And we also need to pass in a position, a vector to I, where we want to display the tooltip or pop-up. Now, here's what we need to do in this case. We need to grab the content container and add the content as a child to it. Now here I did something that I really don't like, and I kind of tried everything to make sure that I can avoid this. You can check the commit messages on the GitHub page for the reference project, but I never could find a more reliable way to make sure that the child is added to the content container than this one. So I really wanted to avoid using await, because what it does here is grabs the scene tree and waits one process frame, because at the next frame, for sure the child will be added to the scene tree. Now, if anyone has any better and more reliable working solution than this, please let me know in the comments, because I'm open to anything that's better than this, but I found this to be the most reliable way to do it. Now, after adding the content, we need to make sure that it gets registered inside the scene tree of the content container, and we can call reset size on the pop-up, which if we hover over, it says it resets the size of the control node to the combined minimum size. And that is what we want, because we can always add different sized content. Also, we'll reuse the same pop-up to display information inside the game. For example, if you use the tooltip to display a very long trade description, but then you right-click on an item where the description only says plus 1080, you want to reset its size because you don't want it to still be this very big pop-up container, because the previous trade display was a big one, right? So you always want to reset it to its smallest possible size after changing its content, and that's why we need this await here, right? Now, when we have the correct size for the pop-up, we can change the global position, and that's where we use this getPositionHelper method that we just created. This will clamp the pop-up between the screen space of the game. We set the mouse filter to mouse filter stop to make sure that the input callback can register the next left click or right click inside the game. And when we're done with all of that, we can call show to actually display the control node. Now, instead of show, you could do tweening here to make it a bit more interesting. You're animating it when the pop-up appears. For the sake of simplicity, I think the code is complicated enough to manage this. So for the sake of simplicity, I just use an instant show and hide. Now, if we have a show pop-up public method to display pop-ups, we kind of also need to have the opposite, right? So we'll also have a hide pop-up method, which is much simpler. We do three things. First, we call the clear method, which again, what it does is it deletes all content inside the content container. We set the mouse filter to ignore to make sure that inside the game pop-up cannot pick up within the input event any left or right clicks. This is not strictly needed because we have this safeguard here, but better to be safe than sorry, right? So we set the filtering to ignore as well. And finally, we call the hide method, which will change its visibility to false. And this means that this guard inside the input callback will work as intended. And one final public utility method we have is called center. And what it does is just changes the global position of the pop-up to the center of the screen. And to do that, we grab the screen size. It works the same way like it did for the getPosition method. And what we do is divide it by 2 and also subtract the size of the pop-up divided by 2 to make sure that the center point of the pop-up will be centered on the screen, right? And with all that said and done, we can save this with Control S. That's all we really need. Hopefully it wasn't too bad. I think that's kind of the most complicated scripting we have to do this episode. And now if we go back to 2D view, we have the center method. So if we go back to 2D view and test running this scene by pressing F6 or clicking on that button, it should center it inside the screen, paying attention to the content it has, and you see it works pretty well. Awesome. But before we move on and just call it a day, let's test the whole thing in isolation, because we have a bunch of other things we can test, right? Like adding new content to it, calling the show pop-up method, or even trying to use positions to display the pop-up which would be outside the screen, right? So let's do that. Let's go back to the script tab, make this a bit smaller, and we can delete this center line here. And what we can do instead is adding some test content. So we can put pretty much any control node inside our pop-up. So let's go to scenes and let's do TraitUI, right? We can just grab TraitUI.tscn, press and hold control while releasing it. So it will preload it based on its unique identifier. And then we can instantiate it. We can clear down the label, and then we can call the show pop-up method in a bunch of different ways. So for example, if we put in the test content and do -5,000 and -5,000, this should be way off to the top left corner of the screen. So if we select all the other versions and press Ctrl-K to comment it out and run the scene again, the clamping works because the pop-up will display at 0, 0, right? Instead of -5,000 and -5,000, which would be way over there. Now, if we go back, we can comment this line and, we can try all the other versions. So for example, 5,000 and 0 should be the top right corner of the screen because 5,000 would be way over there, right? So you can test all these different kind of configurations, but it seems to be working fine. Like 5K should be the bottom right corner of the screen. And you can also combine, legit values with the clamping. So like 500 and 5,000 would be at 500 from the top left, right? And it's clamped on the bottom to make sure that it stays inside the screen. So it seems like a show pop-up method works. And then if we want to do something, we can do something like await get tree.create timer, create a 1 second timer, wait for the timeout signal, then center the pop-up, then wait for 1 second again and hide the pop-up. And this sequence should display the pop-up at that position, then center it, then hide it. Let's see if it works. Displayed, centered, hidden, right? So when you test things like this, make sure that you don't just call it a day after displaying something or testing one method. You need to be thorough to confirm that everything works as intended before moving on to the next part, especially with big systems like this, right? Like a tooltip system, but I'm pretty confident that everything works as expected, so we can delete all this and just leave in that clear line that will get rid of the label that is there for debugging purposes in the scene tree, right? So with that done, we have 51 lines of code. We can save everything with Ctrl-S, and after confirming that it works as intended, we can move on to the next bit. And with the game pop-up ready and functioning, we can actually move on to those specific Tooltip UI displays, one for the items and traits and one for the units. So let's go back to 2D view, click on a plus sign here to create a new scene, and we'll do the detailed tooltip first, which is used by items and traits alike. Let's click on other node here, and the root node this time will be a VBox container. Press enter, double click and rename this to detailed tooltip or something like that. And the way this is going to work is we have a VBox which vertically organizes things. Inside that we have the first sort of row that displays an icon and a title next to it. So press Ctrl-A or click on the plus sign here and add an HBox container, which is the opposite, right? It sorts things into columns. And inside that HBox container for the icon display, press Ctrl-A again and search for texture rect. Select the HBox container again to make sure that it's the parent of the title label as well. Press Ctrl-A, search for label, and this will be the title. And with the root node, the VBox container selected, below our icon plus title combo, we want to have a rich text label for the detailed description. So press Ctrl-A again or click on the plus sign and add a rich text label. So it should look something like this. Now let's rename a couple of things. Double click on the texture rect node and rename it to icon. Double click on the label, rename it to title. Double click on the rich text label and rename it to description. Now with shift, we can select these three nodes, and to make sure that from code we can access them easily regardless of the layout, right click on them and access them as scene unique names. Let's not forget to save this scene because it's still unsaved. Press Ctrl S. And in our tooltips folder, DetailedTooltip.tscn is perfectly fine. Click on save. And now let's set up to make sure that it looks like how we want it to. First, with the root node selected, let's go to theme overrides and set the constant separation value we want. I want this to be pretty tight as we have a pixel art game, so I'll set the separation to 0 and we'll see how it looks and feels like and change it if needed. And for the icon, let's actually load something to see what it looks like. So let's click on a texture here, quick load, and I'll just quick load one of the icons for the traits like human, right? And we need to make sure that the stretch mode is set to keep aspect or keep aspect centered. So if we were to change the size, it wouldn't stretch it on any direction. For the title, we can actually type in something to see what it feels like tooltip title. I just want to make sure that if it ever gets bigger vertically, it's vertically aligned to the center. So let's change that. And finally, for the rich text label, we want to enable BB codes so we can have formatted text. We also want to fit content so it resizes vertically according to the content. And if we paste in some text, you'll see that it's pretty big because it uses the same font as the title does, but we have a much smaller font for this. And also what I want to do is to actually disable auto wrapping in any way. It already looks a lot nicer, and this gives a full control for content creators for the game, right? Because wherever I put a line break, that's where the line break will occur. Now, this could, of course, mean that you have a really wide tooltip, but you can always see how it looks like in game, and I think this gives you the most control over how the content will look like. Now, what we for sure want to change is the font, because that's just too big for the description. So if we collapse this one and go to theme overrides and fonts, we can change the normal font. So let's go here and quick load, and we have our 5x7 font here. And see, it already looks a lot better like this. Of course, you can also add all sorts of stuff like shadows and different colors and things like that. I just leave it as is for now because I'm happy with that. And I kind of like the 0 separation between the rich text label and the HBox container because there's still some space because of the line height that we use for this smaller font. And one thing that we might also want to do is that, this box is a bit smaller than the HBox itself because the icon is taller. So what we can also set is with the label selected, we can go to layout and container sizing, and make sure that it shrinks to the center, but it's already set up this way because if you do shrink begin, it jumps up. So you can do it however you like it to. You can also set it to fill, so it fills the same space as the icon, and then it will make sure that it uses the vertical alignment that we set up. I just leave it as shrink center, but I just wanted to show you that you can control this behavior as well. Now, that's pretty much it for the detailed tooltip. What we can do is we can grab the root node, save everything with Ctrl S, and add the script to it to make sure that we can use it in the game. DetailedTooltip.gd is fine. Let's click on create and see what we need to do here. And here I want to show you a pretty cool technique that is sometimes super useful. So what we'll do first is we'll add a custom class name called DetailedTooltip. And we have 3 already variable references to the 3 dynamic parts of this tooltip: the icon, the title, and the description. And we'll also have a member variable called tooltip data, which is of type DetailedTooltip data. Now you'll see that we instantly get an error message saying that it's an unrecognized type. And that's perfectly fine because we don't have a custom resource or ref counted class with that same class name. We could do a custom resource, right? Or a custom ref counted class for DetailedTooltip data and save it inside the same folder and just have access to it. This data holding class will just define a bunch of things that are needed as data to display inside our detailed tooltip. But one cool trick we can use is called inner classes. So what you can do in Godot is inside the class script, you can have an inner class, which is like a data container that belongs to the parent class, in this case, the detailed tooltip class. And you just don't want to do a separate file for it, right? Because it belongs here. If we pull up the documentation by pressing F1 and search for inner class, we don't really see anything because it's not really connected to any of these classes. But if we pull up the documentation in the browser, we have a small dedicated part to this inside our GD script reference called inner classes. And it says that a class file can contain inner classes. And these are defined using the class keyword. They are instanced using the class name.new function. And you can see that if we are inside the class file, we can just do an inner class with its own functions, its own member variables, and all that sort of stuff. Now, I think the best use case for this is exactly what we do here, a small data holding class that belongs to the parent class. You'll see how that works in a second. For now, let's see what we need to do inside ready. We'll check if we have our tooltip data set up for us, which is that member variable. And if we don't, then we can return from this ready callback because we cannot set up the icon, the title, and the description if we don't have the data for it. So this class expects that member variable to be set up or injected from the outside by the time it is added to the scene tree. And when it does, it's pretty straightforward what we do. We set the icon's texture to the tooltip data's texture, set the title text, set the description text, and set a custom minimum size. So these are the 4 pieces of data that we need to hold inside an inner class. And we use that data to dynamically create these tooltips. And for that, we'll just have a method called setup. And that setup expects 2 parameters. One is a detailed tooltip data and the min x variable, which defaults to 0. And we set the member variable tooltip data based on that. You might say that this is sort of over engineering because we can just have this method pass in the 4 pieces of data itself and set it immediately. And yes, but it's 4 pieces of data, but what if there's 8, right? At some point, it just becomes too big of a function signature. And in this case, it's much easier. We only need to do the min x separately because this way we can provide a default value for it if we don't need to set that up. And this is the inner class definition at the very bottom. That's the important part. So we can just say class detailed tooltip data, and we have a texture, title, description, and the min size with the types associated as well, right? So this way the error messages disappear. We can have our member variable holding the tooltip data. We can use that to set the different nodes properties, the icon's texture, the title's text, the description text, and the description's minimum size. And we can have that setup method, which will receive that outside dependency. I just kind of wanted to show you because I think it's a pretty neat feature that we can do something like this. Again, it could be easily done with a separate resource or ref-counted class. But I think it's nice that you don't need to create a separate file for this when it clearly belongs to this class, right? So I think it's just a really cool use case for this language feature. So let's save this with Control S, and that's all the code we really need. But again, I would advise to test this in isolation, right? Test how we can pass in that tooltip data. And I would say that the easiest way to test this is inside the ready, just assign that member variable and say that, okay, this would be done from the outside, but right now we just do it here. So this is how we can create a new detailed tooltip data reference and set it to our member variable and just set the members one by one, right? So for the texture, we need to load something. So if we take a look at our file system here, we can just search for the elf icon, for example, and if we drag and drop this over, press and hold Control, it will preload it based on the unique identifier. And it should display the elf icon. It would say elf trait, and it would say plus 10% attack speed with a minimum size of 50. So if we save this and run the scene by clicking on this button or pressing F6, you'll see that it works. It correctly displays every little detail we need. And if we take a look at the remote scene tree, the description should have a minimum size of 50 pixels, which we couldn't really tell based on just the output because it's bigger than 50 pixels, but it's set correctly, right? So we can stop this, and we made sure that the detailed tooltip works on its own. Now, if we want to hook this up inside our different systems in the game, we just need to provide these pieces of information, and we can for sure create these tooltips. Now that we know it works, we can just get rid of the testing code, save everything with Control S, and move on to the next one. Okay, so now if we actually want to test this in-game, this detailed tooltip, we need to create that auto-loaded class that manages the pop-ups, right? The tooltip handler. This is needed so we have sort of an API or an access point to this whole tooltip system from all the other systems in the game, right? For example, when I right-click on a draggable bench item, I want to display a tooltip, but I don't have a way to do that yet because we don't have this auto-loaded class. So let's go back to 2D view now. Click on the plus sign again to create a new scene, and let's make our tooltip handler. Click on other node, as the root node will be a canvas layer. Let's double click this and rename it to tooltip handler. Press Ctrl A to add a child node, or click on the plus sign here, and we'll add a timer to this. This will be used for timed pop-up messages without any custom content, with just a label content. But the tooltip itself needs two pop-ups because we have nestable pop-ups in the case of unit tooltips, because when you right-click over a unit, it might have items equipped, and when you hover over those items, then you want to display another pop-up showing the item description. So let's click on the Instantiate Child Scene button, or press Ctrl-Shift-A, and instantiate a game pop-up since we already done that. Let's drag it over the timer, rename it to just pop-up so it's easier to reference inside the scripts, and Ctrl-D to duplicate it, right? So we have pop-up and pop-up 2. We can select both of those, and if we ever want to make some changes to this, but I don't think we do, but just to make sure, we can access them as seeing unique names, so it's easier to reference them regardless of the structure. And we can hide them by default because we don't need to display them only when it's needed, right? And the tooltip handler itself, let's go to layer and put it on the next layer, layer 2, to make sure that the tooltip handler is always displayed above everything else in the game and the game's UI. Now, that's all we really need from the scene tree side. Let's not forget to save this, as this is unsaved, so press Ctrl S. And inside tooltips, tooltiphandler.tscn is fine. One thing we need to set up still is the timer, which I forgot to do. When we want to have timed pop-up messages that appear and then disappear after a couple seconds, we need to make sure that this timer is set to one shot, so it only launches once when we start it and not loops over and over again. Save this with Ctrl S, and let's see what script we need to add to this. So select the tooltip handler, the root node, click on the attach script button, click on create, and let's see what we need to do here. This script couldn't really be easier for now. We don't need to provide a custom class name because remember we want to add this as an auto load, and auto loaded classes don't need to have a separate class name attached to them because that would conflict. So what we need to do is we need to grab 3 already variable references to the 2 pop-ups and the timer so we can have access to them from the outside when we need to. And one other thing we need to do is we need to have a constant reference to the detailed tooltip here so we can always instantiate it when we need it to. And to do this, let's go back to our file system and search for DetailedTooltip.tscn. And we just need to drag this over here, press and hold Control and release it, and we have a constant added, which preloads the scene based on its unique identifier. And that's all there is to it. We can save this with Control S. And let's not forget to actually add it as an auto load. So let's go to project settings, globals. Next to path, just click on this folder here, go to scenes, tooltips, and let's go and add our tooltiphandler.tscn. The node name, tooltip handler, I think is fine. We can just click on add, and it appears here as its own auto-loaded class. Awesome, now we can close this, save the project with Ctrl S, and now we have access to our tooltip handler project-wide. And technically, we could go ahead and set up our traits and items now for displaying the tooltips, but I think we should just do the unit tooltips as well and call it a day, so then we can concentrate on hooking everything up. So let's just do everything else first, and then we hook up everything, I promise. So we need to do the unit tooltip, right? That's the one that we still lack from the project. And well, yes, but at the same time, we need a different scene before we do our unit tooltip. Because if you remember in the unit tooltip, we have items displayed under the mana bar and the health bar. So for that, we don't really have anything, because if we go back to 2D view and press Ctrl-Shift-O and search for item, we only have our bench item now. And if we take a look at that, it's Sprite 2D and the Pack Sprite 2D, a combination of the two, and it's an area 2D. So this is more like a 2D node because we need to drag and drop it around. and make it a part of the game world, but that's not the case for the Units tooltip. We need to have sort of a control node version of this without all the gameplay related functionality. So we don't really have a scene for this yet. So that's another thing we need to do. So let's click on the plus sign. We'll use another node as a root node and search for texture rect. Basically, we just need 2 texture rects. So we can press Ctrl A again, press enter and add another texture rect. For the root node, let's double click on it and call it ItemUI. And for the texture rect, the inner one, let's just call it icon, right? So we need 2 texture rects. For the ItemUI selected, we can just go to texture, click on the arrow and quick load our item background.png. Make sure that it's set to keep size and keep aspect centered so it doesn't stretch. Now it kept the aspect ratio, but this is way too big. So I want this background to be smaller because this is 40 by 40 while the image is just 24 by 24. So let's go to layout, transform and reset the size. You see it snaps back to 24 by 24. And inside the ItemUI, we actually want to grab input with this because if you think about it, when we display this is the Units tooltip, and when we hover over it, we want to display the other tooltip or pop-up with the item description. So if we collapse layout and go to mouse, you'll see that it's by default set to pass, and texture rects don't really pick up any input, but we need to set it to stop so it actually can pick up when we hover over it. Now for the icon, we can just set the atlas texture. Again, it's 40 by 40 by default, so we just need to reset it to match the size of the parent in this case. So let's click on the anchor presets and set it to this one, the full rect. And for the texture, we can just click on this empty and quick load our items.png. And you'll see that this is way too big, right? And if we click on the texture, we can't really change anything. Because unlike in sprites, we can't enable regioning by default with a compressed texture 2D. So if we click on this arrow and reset it to empty, what we need to do here is actually to create an atlas texture. So let's click on the arrow here, and instead of just quick loading, let's create a new atlas texture. And for the atlas texture's atlas property, we can quick load the items.png, this one. And now we have a region that we can set up. So what we can do is we can set the width and the height to 32 by 32, and you can immediately see the effect of it. And you know this is 32 by 32, which is bigger than the background that we have. If you don't like it, you can change the background to be bigger. But if we click on edit region and select the items that we have, like the ring, then you can see that we have a really big borders around it, so it still fits. But with bigger items, it might happen that it doesn't fit to the background. So if we select this stuff, you see it overflows a bit. If you don't like that, you can just make this ItemUI bigger. So if we select our ItemUI, the parent node, we can just make it 32 by 32 or even bigger, 36 by 36. And that would for sure contain all the icons that we have inside. Like if we select this stuff, it still a bit overflows, but you can make this one smaller if you wanted to with scaling it down or just make everything a bit bigger. I just don't want to spend too much time on this because it's something that is easy to tweak. So I just set it back to 24 by 24 and call it a day. Yeah, it doesn't look too good with this one, but the items that we do have inside the game, like the gloves, it's pretty okay, right? Now, what's more important is that we have this atlas texture connected to the icon, and we need to change this from script based on the item that we are actually displaying, right? So I don't think there's anything else from the inspector side that we need to change. For the inner icon, we don't really want to register any mouse events, so I think we're fine. We can just select the root node, the ItemUI node, and attach a script. But before we do that, let's not forget to save it actually first. So let's press Ctrl S. And this I would not put into tooltips because strictly speaking, this is just a UI representation of an item, and this could be reused elsewhere in the game. So instead, I go back one folder and create a new folder for this called ItemUI. But you could put it with the tooltips if you wanted to, because for this demo, we'll only use it for the tooltips. But again, this could be reused elsewhere. Let's save it and attach a script to it to make sure that we can change it dynamically. Click on create, and let's see what we need to do here. Now, let's see how we can make that nested tooltip kind of thing with this. First of all, we'll provide a custom class name called ItemUI. Then we'll have an export variable called item, which expects an item resource. So we know what item this UI piece represents. Pretty straightforward stuff, right? Now this will have its own setter function, so when the item representation changes, we can update the UI to reflect those changes. First, we just set the item to the new value that we want to set. Now, if this happens before the node is ready in the scene tree, we can return, because this means that the inner texture rect, which represents the icon, is not yet ready inside the scene tree. Now, if we have an invalid item, or this export variable item slot is empty, it means that we need to hide the icon, because that slot is not taken or not representing any items yet. We have this error message because icon is not declared yet, but it will be a member variable referencing the icon texture rect. It's just that export variables should come before already member variables, right? And after hiding the icon, we can return from this method. But if we do have a valid item resource and every node is ready in the scene tree that we need, then we can update the Atlas texture's position based on the item resource and the arena cell size, and also show the icon so the item appears. Now we can get rid of these error messages by providing an already variable reference to our other texture rect. And inside the ready callback, we need to do a couple of things. First, just to make sure that we can actually test this, when the node is ready in the scene tree, we can set the item property to itself again, which makes no sense if you think about it, but it kind of does, because export variables, if you remember, are set before everything is ready in the scene tree. So if we set it from the inspector to test it to an item, then this guarding if statement will return sooner than we can check everything working. But if we reset it again, it will trigger the export variable setter function again after the node is ready in the scene tree, so we can actually see if it works or not. And besides that, we need to do two things. We need to connect to the mouse entered signal, and we need to connect to the mouse exited signal. Again, because this is a nested kind of tooltip, which will appear inside the units tooltip. So when the mouse is hovered over this item UI, we want to call a method called showTooltip, which we are yet to implement. But if the mouse exits, we can actually use the auto-loaded singleton and say that the tooltip handler's popup to GamePopup should be hidden, and we have a method defined for this called hidePopup, which we can call from here or connect to it from here, right? And that's kind of the power of singletons. Again, this creates a tight coupling between the item UI and the tooltip handler, but in this case, I think it's fine. Like, if it's a tooltip related scene, it's not a tragedy that it has awareness of a tooltip system existing. Now, we also provide a sort of utility function here that gets the item tooltip and returns the detailed tooltip control node. This uses the item resource to generate the tooltip instance base from it. So what we need to do here, first of all, is we'll instantiate a new detailed tooltip. For this, we use the constant that is found inside our auto-loaded class. Remember, if we press and hold Ctrl and click on it, we have this constant preloaded here, so we can instantiate these whenever we need it. So we'll instantiate one and typecast it to a detailed tooltip, so we have access to all auto completion. And before we actually add it to the scene tree, we need to provide the data for it, if you remember. So what we do is we use new tooltip, which is the instance we created. And since we have the inner class, we can do new tooltip.detailTooltipData.new. Then we set the texture to the same one we have for our icon with duplicate, set the title to the item's name, and set the description to the item's description. And then with everything ready, we can call the setup method and pass in the tooltip data, that ref counted reference that we just created, as a parameter. And this is cool because we know for sure that it will be set up before actually adding it to the scene tree, because to do that we need to call the Popups showPopup method. But we don't do it here. This is just a utility method that creates the detailed tooltip, passes in all the data needed to it, and returns it from the function, because that's the line that we are still missing here. Return the new tooltip. Now this utility method can be used inside our showTooltip method, which we connect it to the mouse entering this item UI. And now what we do here is first a safety check. If we don't have a valid item, it doesn't matter that we hovered over this item UI, we don't want to display anything. Or if the tooltip handler is already busy showing the second pop-up, this nested pop-up, then we cannot show multiple ones at once. So in this case, we can return immediately. Otherwise, we call the tooltip handler's popup tools show popup method. And as a control node, we call this utility method we just created with the properly set up detailed tooltip instance. And we just pass in the global position of the ItemUI to display this tooltip at. And the final thing we need to do, which is super important, is call the get viewport set input as handled. What this method does, if you hover over it, it stops the input from propagating further down the tree. So we say that it doesn't matter if you hovered over somewhere else, it won't be treated in the game. It kind of is a way of saying that this input that caused this method call, which is in this case the mouse entered signal, won't be reused anywhere else in the project, right? Okay, this was a lot of talking, but hopefully it makes sense. It's not too bad, I think. We can save the script with Control S and we can actually test it in isolation, right? So if we go back to 2D view, the ItemUI's export variable should be empty because we just created the script. And if we run the scene or press F6, what should happen is that the icon is not displayed, right? It's hidden. And if I hover over it, nothing happens. No tooltip is displayed. And that's exactly what I want to happen because there's no real item attached to it. Now, if we stop the game, select the ItemUI again, and do load one of the items, like let's say, I don't know, the ring, and run the scene again, now we do have an icon displayed. It's the correct one. And if I hover over it, something happens, but it's a bit weird, right? Okay, so the tooltip does get displayed and it's correctly cropped or clamped inside the screen space, but sometimes it's just flickering really bad, right? So what happens is the tooltip gets displayed on top of it and it keeps hiding and displaying it because the mouse entered and mouse exited signals are fired a lot of times. Now UI can get tricky, but a cheeky way to solve this is just actually offsetting the global position and say that the tooltip should appear next to or under the ItemUI, right? So one way to solve this is to say that, okay, we use the global position, but we can also use the ItemUI size and just offset it to the right. And if we run it now, what happens is the tooltip will be appearing next to it no matter where I hover over it, and the flickering kind of stops. If you are really precise and hover over it, the right edge, you can still get a bit of a flickering. So if you want to make sure, you can use a bigger size or leave a margin, right? So we can do size.x plus, 8 pixels. And in this case, if we save it and run it again, it appears next to it. Maybe 8 pixels is a bit too much for a pixel game. We can do 6 or something like that, but it's really hard to get it flickering now because it appears next to it. So you can play around with those values. That's the easiest solution I can think of, right? It's just moving it a bit away from the item's description. Of course, you don't want to leave in magic numbers like this. So if you do end up using a margin, you can set this an export variable as well. So we can do something like adding another export variable called tooltip offset and make it a vector 2i, right? It's 0, 0 by default. It appears immediately. And we can use tooltip offset.x and tooltip offset.y on the y as well. And this way we have this nice offset, which we can set from the inspector if we wanted to. And we can set something like 6 pixels on both axes and test it like this. So you can tweak it however you want it to. I don't think that's too bad, actually. Maybe I'll leave it like this. Yeah, pretty cool. So we know that the ItemUI works on its own. And if we are sure we don't have any extra testing code added to this, it works as we expect it to. But when we go back to 2D view, we can actually set it to an empty item by default because most units, when the game starts, won't have any items attached to them, right? So we make sure to leave it at empty and only change it if an item gets equipped on a unit. Awesome. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. And now we have everything to create the one final missing piece of UI for these tooltips, which is the unit tooltip, probably the biggest one. So let's click on the plus sign here to create a new scene. Click on other node, and the base for that will be a VBox container, very much like we did with the detailed tooltip. Press Ctrl A or click on the plus sign. So let's add everything first. We'll add an HBox container because at the top we'll have the tier icon and the unit's name next to each other. And we can add those as well. So with the HBox container selected, press Ctrl A again. We'll use a label for the unit's name, but for the tier icon, we already have a scene that we can reuse. So with the HBox container selected, click on the Instantiate Child Scene button or press Ctrl-Shift-A and search for tier icon.tscn. Now let's make sure that the tier icon appears before the name. Then the next one we'll have is a health bar and the mana bar, and we have scenes for that as well. So with the VBox container, the root node selected, press Ctrl-Shift-A again, search for health bar first, then select the root node again, instantiate the child scene, add a mana bar next. And finally, we need to add the items. I know it looks ugly right now, but bear with me. So with the VBox container selected, press Ctrl-A again. And we want to add the items next to each other, so we'll use an HBox container for that. And inside that, we need ItemUIs, the scene that we just created. So let's click on Instantiate Child Scene and search for ItemUI. And we can press Ctrl-D to duplicate it 3 times. Now that's all we really need, but let's rename stuff so it's actually a bit tidier. Double click on the root node and rename it to UnitTooltip. The HBox container can be title or something like that. And the label can be unit name. And while we're at it, let's just type in Bjorn or something like that, so it looks a bit nicer. For the health bar and the mana bar, the biggest problem is that we don't have a minimum size value on the Y, so they need to be a lot taller, especially if we want to add labels to them. So let's select both by pressing and holding Control, go to Layout, and set a custom minimum size of 16 pixels. Now it looks much better, right? Select the second HBox container and double click on it and rename it to Item Container. And we can rename those from ItemUI, just item, right? And just duplicate it 2 times again and delete the other 2 because I'm too lazy to rename them. And item 1 can be item 1 as well. This will make it easier to handle this from code. And now what we need to do is make a bunch of these nodes scene unique. But before we do that, let's add some labels to the health and the mana bars because we need those as well. So with the health bar selected, let's add a new label node, rename this to health label. And I think it's easier to set it up once and just duplicate it under the mana bar instead of doing it twice. So before making anything else, let's just create those labels, right? The first thing we want to do is to make sure that the anchor preset is set to full rect, so it fills out the whole health bar. And for the text, we can type in something to test it, like 0 out of 1,000, and center it on both axes. And for this one, I think it's worth to create its own label settings resource because I don't really like this font for this, and we also need an outline. So instead of what I did, I just created a new label settings resource, and I've used the other font. So for the font, we can just quick load our 5x6 one. It looks much nicer in my opinion. And we can also add an outline, which is fully black. So it's easier to read even if the bar gets filled or looks different. And I think 1 pixel is definitely not enough. So let's do a 2 or maybe even 3 pixel outline. And I think it looks much nicer now. It's easier to read as well. And now if we have this, we can duplicate it and just add under the mana bar the other one. Let's rename it as well to mana label and reset the anchor presetting to full rect so it moves. And we can set it to different text if you want to see how it looks like, but it doesn't really matter that much. Now that is much nicer. And now we can actually set all the different scene unique names. So we can code this. We need a tier icon, the unit name, health bar, mana bar, health label, mana label, and the item container. So almost all nodes need to be accessed from code here. Let's right click and access them as scene unique names. Now we could spend some more time tweaking with the values, with the different separation values for the boxes, but I kind of like the defaults here. I think it's a bit nicer to have some separation between the elements. I think it looks kind of okay by default, but if you want to, you can tweak these settings as well. Now let's not forget to save the scene because we haven't saved it yet. So press Ctrl S and we can go back to the tooltips folder now, I think, because it makes sense to save the unit tooltip there. Save it as UnitTooltip.tscn. And now we just need the script to sort of glue the whole thing together and provide the functionality we need for the unit's tooltip. The good thing about this is that it's not too complicated because the ItemUI already handles managing the nested tooltip, so I think it won't be that hard. Let's attach a new script to it. UnitTooltip.gd is fine. Click on create and let's see what we need to do here. So we'll have a custom class name called UnitTooltip, and we'll have an export variable for the UnitStats resource. Now this for sure needs to have its own setter function because the tooltip changes when the stats change. First of all, we just set the stats to its new value when we change it. Otherwise, we need to check after changing it if it's a valid stats resource and the node is ready inside the scene tree. If both of these are true, it means that we need to update our tooltip, right? So how do we do that? We'll grab a bunch of already variable references to all the stuff we need. And the tier icon, the mana bar, and the health bar are already their self-contained UI pieces, which also have access to a UnitStats resource variable. So we just need to inject that dependency to them so they can manage themselves. For the unit name, it's easy. We just set the text to the stats name, right? And after all that, we need to connect to the stats is changed signal because, we need to update a bunch of stuff when the unit stats changes. And also we call it manually as well once because setting a new value means that we need to trigger that change to update the health, mana values, and so on. Now the tricky part for this is that we also need to have access to an item handler node. And the reason why is because we need that information for the currently equipped items and also connect to the signal when the items that the unit has equipped change. So we do pretty much the same thing, right? We set the export variable to the new value inside the setter function. And then we check if we do have a valid item handler and the node is ready inside the scene tree, we need to connect to the item handler's items change signal to our own callback method and also call it manually once. And this callback method will handle displaying the currently equipped items on the unit. And then to make a bunch of errors disappear, we just need to have a lot of already variable references to all the uniquely named nodes and scenes that we have inside this unit tooltip. Inside the ready callback, we do something very similar that we did with the ItemUI. We just reset the export variables to the same values that they have inside the ready to make sure that these safeguards pass when these unit tooltips are instantiated and ready in the scene tree, right? And then we need to have those two callback methods. So when the stats change, what we do need to handle ourselves are actually just the health label and the mana label because everything else is again self-contained. So for the tier icon, the health bar, and the mana bar, they have their stats resource injected to them and they connect themselves to the stats change signal and handle everything they need. But here we added labels as well, right? Which are new additions and they're not their own scenes. So we need to update them when the stats change. Here I just did the simplest version of this, which is setting the text to two string placeholders. One is the stats.health and the other one is stats.getMaxHealth, and the same for mana. I'd like to call out two things here. A lot of stats are missing, and also this is just a bare bones representation of the health and the mana label. This does not take modifiers into consideration. So if you were to use this in production or use this project structure or demo or whatever we call it for your game, here you need to take care of having access to a modifier handler as well, because in reality, stats like health and mana could be modified, right? Here, I just went for the simplest solution. Just a quick side note here. Now we need the other callback for the items changed, and it's a bit trickier than when the stats change. What we do is we grab the item containers getChildCount, and if you remember, that's an HBox container where we have our item UIs instantiated next to each other. So we'll have I as an integer. If we have 3 children or 3 item UIs, I will be 0, 1, and 2 respectively. Now, why do we need this? Well, first of all, we can use the getChild at I to grab the item containers nth, or in this case, ith child, and cast it to an item UI to make sure we have auto completion. And then we need to check our item handler export variables, currently equipped items, to see if we can sync them up. By default, we say that the item we have is null, so we don't have any item in the item handler. And then we can check if we actually do. So we see if I is less than the size of the equipped items array. For example, if a unit has 3 equipped items, size would be 3. So both 0, 1, and 2 will be less than that number, right? So this is just a safeguard, and if it is less, it means that the item handler might have a value an actually equipped item there. So we override that initial null value we have with the item handlers equipped items member at I, right? And finally, we either have a null item because there wasn't an item equipped for that unit, or we grab that at the specific slot where we are currently at, and still within the loop, we set the ItemUI's export variable to that item property we just grabbed. This makes sure that every time the items change inside the item handler, the tooltip will have the latest version showing. Pretty straightforward, right? It's 50 lines of code. I hope it's not too bad. Now we just need to test it somehow. So we can actually save this with Control S. And if we go back to 2D view, we see two things, right? We need to have our stats provided for the unit stats resource, and we need to have an item handler so we can actually test things out. Now, if we want to test this in isolation, it's pretty straightforward. We can actually load any unit stats. So for the stats, we can just click on quick load and load Björn. But for the item handler, we need to add one. So temporarily, what we can do is we can grab our unit tooltip, the root node, press Ctrl A, and just add an item handler. Since it's a node, it can be added to anything. We need to quick load our item DB and set some equipped items, right? So let's set 2 and quick load a ring and I don't know, maybe gloves, right? So now we have an item handler that we can test this tooltip with. We just need to actually assign it, right? So if I select the unit tooltip again, click on assign, we can select an item handler. So we have both that and a stats resource. And if we go back to the script, inside the ready callback, we can add some lines to actually do something to make sure that it looks all right. So when we reassign the stats and the item handler, we can do something like this, set the tier to 2, reset the health, reset the mana, and add some mana to it. Of course, again, if you want to, you can add some timers between them, like waiting 1 or 2 seconds to see if it updates. But let's just test it first. So if we run the scene or press F6, we'll see that we have Björn, 28 mana, 50 health, tier 2 icon displayed, and we have gloves and ring, which is fine based on the description, but for whatever reason, it didn't really update our icon, right? It uses the same icon, and I think it might be because they share the same resource, but we'll have to investigate. But everything else seems fine. The labels are updated, the mana bar, health bar is fine, the tier icons are okay as well. Yeah, but the icons are not the best. Now let's investigate why that happens. So if we test it again, you hover over it, you see everything else updates, it's just the icon that doesn't. Now that's suspicious, right? So if we go to the remote scene tree and check our item container, we have item 1 and item 2 here. Of course, the item resource itself is fine because the description and the title is different for them, but just to double check, we can make sure. If we click on item, it should say ring for the first one. If we click on the item, it says gloves, right? So far, so good. Now, if we take a look at the icon, which actually displays the icon, we have this Atlas texture loaded, right? And inside the script, if you remember, if we go back to the script and ItemUI, what we do is we update the texture resources regions position property. Now, it probably is a case of sharing the same resource between the two instances, but if you want to double check it, a quick way to check our theory is to actually go to the item handler and just flip the order, right? So now the gloves will be the first and the ring the second, and if we rerun it, we have 2 ring icons, right? So the order of the items matter a lot because the icon we use will be the last one actually, which is a clear indication that they share the same resource, these 2 item UIs. And that's a really easy fix actually. It's just something I forgot to do when we did the item UI scene. Do you have any guesses how we can fix this? If we select the icon and click on the Atlas texture, this is the texture we created, right? We load the whole item's image and set the properties for it. The Atlas itself is its own resource, and the Atlas texture itself its own resource. So if we click on it and collapse it, we'll see that it's the resource that we added. And this resource, the upper one, the Atlas texture, is the one that has all these properties, right, where we position inside the region. And since all item UIs share the same Atlas texture resource, they can have separate icons. So the quickest way to fix this, make sure that this is the resource that we selected, the Atlas texture, is just to go to resource and enable local to scene, right? Because it says that the resource is duplicated for each instance of all scenes using it. At runtime, the resource can be modified in one scene without affecting other instances. Now, this is perfect for us if we save it for Control S, because we do instantiate ItemUIs, right? So when we create the separate dynamic instances of it, they will all have their own Atlas textures. Now, we don't want to do that for the Atlas itself, right? This image, because these can be shared between the instances, right? It's fine. And even better, it's just saving performance if we only load it once. But this is the one that we want to load for every separate ItemUI to change their region separately. So with that little change, if we rerun the scene, we have working icons because setting those coordinates will be now local to all the scenes, right? Pretty awesome. Again, if we just reorder them and rerun the scene, it doesn't matter now. The icons will be updated as well. Pretty cool stuff. So I think that kind of confirms that everything is working properly, and we can go back to the script of the UnitTooltip and get rid of all these testing code. Again, if you wanted to, you can test it differently, adding the timers between them. But I think we can confidently say that this works. So we can delete the testing code, save the script with Control S, and move on to actually hooking up these tooltips inside the already existing game systems. Hooking up will be fun, and it's much more rewarding than just creating these separate UI scenes, so I hope you'll have fun with the second part. One small thing that we need to do before we start that though, is going back to our tooltip handler singleton, and make sure that we have access to our detailed tooltip as a constant so we can instantiate it somewhere, like we did with the ItemUI. But we need to do the same for the UnitTooltip, so it can be accessed and instantiated anywhere that's needed. And to do that, we just use the file system and search for unit_tooltip, grab the TSC and press and hold Control while releasing the mouse button, and then we have the other constant for the UnitTooltip, accessed as a preloaded pack scene resource. Save the script with Control S, and now we can actually start hooking up things. And the first thing is hooking up the units, right? We did the UnitTooltip, why not start with that? And here we have a bit of a problem, because actually you can display tooltips on both battle units and simple units, right, for the planning phase. And that's a kind of a problem because we can't use the unit or the battle unit classes themselves to set up the tooltip management, because that would make our code redundant, right? We would have to do it in two different places and we essentially do the same thing. So instead we can just create a custom node for it and slap that node on both of those. But before we do that, another thing I forgot to do is actually deleting this item handler placeholder here, right? It's not part of the UI, so we can select it, press delete, and delete it. So now we can reset the stats and the item handler export variables as well, just to make sure that we have a clean slate for this UnitTooltip, and save it with Control S. Okay, so making this will be pretty straightforward as it's a single responsibility custom node. So let's just clear the filter from the file system and collapse everything, and we can use our custom nodes folder here. Right click on it, create a new script, and we'll call this UnitTooltip handler or something like that, right? Click on create and double click to open it up in the script editor. And this will be super simple, I promise. First, we provide a custom class name called UnitTooltip handler. Then we'll provide an export variable for the unit. Since we want this to both be usable for units and battle units, we can confidently say that both of those are area 2Ds. So we can just say that the unit export variable is an area 2D, and we check for the specific types when it's needed. Now inside the ready, what we do is we grab a reference to the unit and connect our own callback method to its input event signal. This is a signal that is available for area 2Ds for managing input on them, right? We'll also have a utility function similar to what we had for ItemUIs called getTooltip, which will create our UnitTooltip control node for displaying the tooltip. And what we do is a safeguard here, right? So we need to make sure that the unit is either unit or a battle unit. If it's neither, we can return from this method because we actually don't want to do any tooltips, right? But if it is one of them, we'll grab the tooltip handler's constant for the UnitTooltip pack scene, instantiate it, typecast it to a UnitTooltip, and store it in a variable. Now we can inject both dependencies, right? We have those dependencies as export variables. We assign the stats from the unit, and we'll also assign the item handler, which we know that both the battle units and the units have. So this is safe to do so. And then just return the new control node from this method. And finally, the input event callback is where we actually want to handle clicking on the units for tooltips, right? So first what we do is we check if the action that was pressed is a tooltip action, which is the right mouse button. And if so, we'll use the tooltip handler's popup to show our first popup. For the control node of the contents, we just call the getTooltip, which instantiates and sets up our UnitTooltip instance, and use unit.getGlobalMousePosition to grab the unit's position where we want to actually spawn that tooltip. Now, again, it's really important here that if two units are standing on top of each other, we don't want to accidentally try to spawn two tooltips, right? Because that would lead to kind of unexpected behavior. If I register both units right clicks, then I would call show popup twice really quickly after each other, and I don't really want to do that. So if I click on a unit and I can show this pop-up, I want to again set the input as handle to make sure that no other node from the whole scene tree can register this right click, right? And that's about it. It's pretty straightforward in my opinion, since it handles this single responsibility. You just need to set out that export variable and then we're good to go. So let's save this with Control S and actually add these tooltip handlers to both the unit and the battle unit. Let's go back to 2D view, press Ctrl-Shift-O and search for unit.tscn. And we can just select the unit, the root node, press Ctrl-A to add a new node and search for UnitTooltip Handler. Press Enter. It's actually fine at the last position here. And let's not forget to assign that export variable. Double click on unit and we're good to go. We could add an already variable reference to this tooltip handler, but we don't really need to, right? It handles everything on its own, so we can just leave it as is. Just save this with Ctrl-S, press Ctrl-Shift-O, search for the battle unit. Now it has a lot more nodes, so let me just make this bigger. Select the battle unit, click on the plus sign, add another UnitTooltip handler. I just move this above the animation player to keep things the same way. Again, click on Assign. And you see I have a lot more area to these I can assign here, so make sure you select the battle unit and press Ctrl-S as well. Now this simple change, in theory, should mean that if we play the game and buy a couple units, drag them over, I can right click on it. Oh, and it works. Pretty awesome, right? If I click anywhere else, the tooltip disappears either with the left or right mouse button. So that's the reason why I went with my own solution. If I left click here on this robin, I expect two things to happen. The tooltip to disappear and this click to go through and still buy the unit. And it happens. So I'm pretty happy with this solution. And I can just drag over items. They should be there. I can hover over them. If I drag another one over, it will say ring ring. So it's pretty much working. And if we run a battle, I can still right click on the unit and get the updated version of the health bar and mana bars. I could do the same for zombies, you see. Pretty awesome stuff. So it was easy to hook up the UnitTooltip system once in place, but we still have a couple of things to do. And the next one would be items. Let's just close these scenes for now because it's getting a bit messy. Let's close all the tabs, search for our arena scene and play the game. So now what happens is I have these bench items I can drag around, and if I right click on it, I would expect the detailed tooltip with the item description to show up, but we still not have that working. So let's do that next. And to do that, let's go to the script tab. Again, we can close everything to make sure it's organized. Press Ctrl-O and search for bench_item. This is where we handle anything related to the bench items, right? So that's where we need to make our change. Now, what do we need to do here? First, inside the ready callback, if we're not inside the editor, because this is a tool script, so if we're inside the game, we need to connect to another new signal, namely the input event signal again, because we want to register right-clicking on that area 2D that the bench item is to know that we can display a tooltip safely. Of course, we get an error message that we need to implement this. Now, it's a safe bet that we actually want to do a very similar thing that we did with the other ones, namely providing a utility function for getting the tooltip control node. In this case, it's a detailed tooltip, where we set up everything and pass the parameters as we need them. So then inside that actual onInput event callback, we can just call the TooltipHandler singletons according functions. So let's create that helper function first. And it looks something like this. We return a detailed tooltip. Again, we instantiate a new detailed tooltip, cast it to the appropriate type, so we get auto completion. Create a new detailed tooltip data, that inner class that represents the data structure for it, and set everything. Now here we have a bit of a problem because we have the item resource, so we can have the name and the description and call the setup method, but we do need to pass in the texture as well. And that's a bit tricky because if you remember, the ItemUI uses an atlas texture to use those coordinates that we have. But if you go back to 2D view here and press Ctrl-Shift-O and search for our bench item scene, click on the PackSprite 2D because that's what we use. And if I hover over the texture where the items are, it's a compressed texture 2D, not an atlas texture, right? And we have this edit region, but for sprites, it's a different thing, and we don't need to create them as atlas textures. And that's a problem because our ItemUI expects an atlas texture. So with a quick detour, what we can do is we can say that we provide a conversion function inside our PackSprite 2D component. So if we click on the script, it's a pretty easy script that we have for the PackSprites, right? And we can just do something like this. We'll call this method getTexture as atlas. It returns the texture, and we create a new atlas texture, set the atlas to the texture that the sprite currently has, and set its region equal to the region rect that the PackSprite 2D has, which will have all the properties, the width, the height of the cells, and also the XY coordinates, and return the texture. And now we actually have something to type here, because then we can just say PackSprite 2D.getTexture as atlas. And we don't have code completion here because I haven't saved the script, but if we save it, we can use getTexture.atlas like so. Hopefully that makes sense why we need this. I'm sure there might be a better solution for this, but that was just a quick fix to the problem that I faced when I was making the reference project. But now we have the appropriate method for getting the tooltip for the bench item, and we can actually override that onInput event callback when an input event occurs. Let's scroll all the way down and edit here. And you won't be too surprised, it's really similar to what we did with the other ones. We check if the action on the item was a tooltip request, meaning the right mouse button. Then we just grab the tooltip handler's first popup and call the showPopup method. We'll grab the control node, the detailed tooltip, with the method we just added, this one, and get the global mouse position that we currently have. And to make sure that we don't conflict these requests with other ones, we set the input as handled for the viewport. And that's pretty much it for hooking up items. If we save this with Ctrl-S, we added no new export variables or anything like that. Everything is handled via code. We added a new signal, that helper method, and that callback method at the bottom. So in theory, if we play the game again, we can right-click items now, and we get the descriptions. And you can see that for the sword that sits at the bottom, clamping the pop-up still works because it's sticking to the bottom of the screen. And we have the proper descriptions for all the items. If I right-click on another one, that's another thing I wanted to do. If I right-click here, hovering over the ring, what I expect to happen is with one click, the sword tooltip disappearing and showing the ring instead of it. So these are the small nuances I couldn't get working with the built-in window and pop-up system. But here, as we have full control over it, it's just much more pleasant in terms of UX. At least to my abilities, you know. Okay, so we hooked up the bench items as well. I believe there are just a couple things left to do. We need to provide trait descriptions and also some timed messages, like when the bench and the area are both full and you are trying to buy a new unit. Okay, so let's do the TraitUI next. I think by now you are pretty familiar with the workflow that we do. We usually handle somehow the input events and also provide a utility method for instantiating and setting up the proper tooltip. And inside the ready callback, we connect to some sort of input signal that we need to. You're not wrong, that's pretty much what we need to do with the TraitUI as well. So if we press Ctrl-Shift-O and search for TraitUI, Let's go back to 2D view for a sec, just to remind ourselves that this is what's displayed for the active traits on the board, on the left side of the screen, right? So this is a panel container, the root node, and for the mouse, it's set to filter stop, which means that for the whole TraitUI, we can actually grab and intercept input events. But if you take a look at node and signals, it's a bit different for control nodes because it's not called input, like with area 2Ds, it's called GUI input, right? So this is emitted when the node receives an input event. We can either use this, or we can use the input callback itself when we want to handle right-clicking on a TraitUI. Just to keep things similar, I think both is fine here. I guess it matters a bit in terms of UI execution. There's a using input event documentation page which explains this very nicely. So what you do is kind of a hierarchy when you pick up input events, right? So you have input event and you have GUI event. So you see that if you override the input event callback, it actually happens upper in the hierarchy than the GUI event does. And then you have unhandled input event at almost the bottom. And it's very well explained in like this ordered list. So if you take a look at 3, right? First of all, the standard node.input function will be called in any node that overrides it. If the function consumes the event, it can call set input as handled and the event will not spread anymore. And this is what we did, if you remember, with get viewport that set input as handled. This ensures that you can filter all events of interest even before the GUI, right? This is what we did with a lot of area 2Ds. And then you see if it wasn't consumed that event, then it will try to feed into the input to the GUI and see if any control node can receive it. If so, then the virtual method GUI input will be called and the signal will be emitted. So it's really up to us whether we connect to the signal, we override the input virtual method, or we override the GUI input virtual method. It doesn't really matter in this case. If we want to make sure that the tooltip kind of overrides everything, then we can use input here as well. In the example, just to kind of showcase multiple ways of handling input inside games. It's not a best practice by any means, but here I used the GUI input signal just to show you that there are different ways to handle the same thing. I don't think it really matters much in this case. Anyway, so let's click on the TraitUI script. And first let's provide a helper method to get the trait tooltip. We can put this above the setter methods, I think, and it will be pretty straightforward. We'll create a detailed tooltip, again, typecast it, create the data from the inner class, and we set the texture from the trait data resource, the name, and the description. And here I actually used a minimum width of 150 pixels, so all the trait descriptions can be pretty wide. I imagine in production, the trait descriptions might need to be a bit longer compared to item descriptions, for example, so I think it looks nicer if it has more space. But of course, you can use any value you like. Now here we can do a bunch of stuff, right? Like we can connect to the GUI input signal, we can override the input or the GUI input methods. Again, just to show you a different version, we'll just override the GUI input virtual method. You see, it's pretty similar to input as it receives an input event as well. And here what we need to do is we need to kind of do the usual, right? We check if the tooltip action was pressed. If so, we'll grab the singleton, show the pop-up, get the trait tooltip, get the global mouse position. The only difference is with GUI input, you can call this method called accept event, and it marks the input event as handled. Kind of does the same thing as get viewport that set input as handled, but this is exclusive to control nodes, right? When they receive input through GUI input. Again, I kind of just wanted to demonstrate the different ways and this hierarchy that I was showing you earlier in the docs page. Right, so let's save this with Control S and we should be good to go. So if we play the game now, buy a new Robin, drag him in, now we have the elf, and if I right click on it, I should have a description, but it kind of says nothing because I think the resources are not filled out properly, which we can make better in a second, but we actually do have a bug which I want to show you. So if I right click here, it kind of works, right click here, it works. But if I specifically right click on the number here, the 1, see, I'm clicking like crazy, which you can see right now, but it doesn't really show me the tooltip. And in this case, the usual culprit is something consuming the mouse input event. So we want the TraitUI, the panel container root node, to consume this event. But if we go to debugger, make it maybe a bit smaller and go to miscellaneous, we have this, which is really helpful, right? The click control and click control type. So if I right click on this, it says the click control is the margin container or something like that, which has the pass or propagate mouse filter. So it passes all the way up to the TraitUI, the root node. But when I right click on this number, you see it is the rich text label, which is called trait level labels. And probably the reason why we don't see the tooltip is because it stops propagating the input event upwards. So if we stop the game for now, go back to 2D view and select our trait level label, this rich text label, go to the inspector and scroll to mouse. You see it's set to stop. So if I right click within this rectangle, nothing gets displayed because it consumes the input event. If we set it to pass, it's called propagate up, and this was the margin container, for example, right? It set the margin container, but it propagates upwards in the scene tree until someone receives it, right? So we can either set it to pass, that works, or we can set it to ignore, which completely ignores the input events as well. So this way we cannot really click it in any way. So we just set it to ignore, save this. And while we're at it, let's update some of these descriptions, right? So let's search for elf.trs, and you see the description's empty, so it's kind of hard to test. But we can do something like elves get 10% or 25% bonus attack speed. Again, if you wanted to, you can go crazy. It's BB code enabled, so you can highlight the number that you still have if you provide a utility function in the trait resources script. Right now, I'll just keep it simple. I don't really want to make it dynamic, but we can also edit the Viking because we have that berserk state. So if we press Ctrl P and search for Viking.tres, again, we can fill out the description, something like when Vikings fall below 75% HP, they berserk, getting a 70% attack speed boost. Save both of these with Ctrl S, play the game, buy Robin and look for Bjorn as well. We'll see both of these traits active. Right click on it, you see we have this nice little description now, and I can actually right click on the numbers. It's working now with ignoring the mouse input. And you see, I think that 150 is pretty nice. It's a length that is still comfortable to read. And you have the full control over putting the new lines in the description box to make sure that it appears however you like. And with that done, I think we hooked up all the tooltips that we need inside the game. The final thing to do is to actually display messages, like when you have a full board and you're still trying to buy units. Now let's do those timed pop-ups that we are talking about. First of all, let's press Ctrl+O and search for Tooltip Handler, because right now we kind of only have references and constants here, and we aren't providing a way to use the timer that we had set up for timed messages. So let's just change that with a quick little utility function that we can use. Let's call it show timed popup, and we'll pass in a message as a string and a time in seconds as a float. And what we'll do is we create dynamically a new label node, set the text to the message, call popup.showPopup, and use await here. The reason why we need to use await here, if we press and hold Ctrl and click on it, is because it has await as well, right? To make sure that we only proceed with this function when that popup already has its content added to it and recalculated its size, right? That's why I don't really like using await, because I think it gets confusing very quickly. So if I click on this, you'll see I have an await here. And to make sure that this whole thing, the whole function is executed before I move on, I need to use await here as well. That's how coroutines work. So what we do is we call that method and make sure that everything in it executes, right? Meaning that we wait one frame, do everything else, and then we center it, and then we set the timer's wait time to the time that we pass in as a parameter, start the timer, and we need to do two things. And this is a bit tricky, but you need to think about it. When the timer times out, we just want to hide the pop-up, right? And we connect it with a one-shot flag, meaning that, we hide it once and then disconnect from that signal. But it might also happen that the pop-up will be hidden before the timer runs out. How? Well, if you remember, if we click anywhere on the screen, or if we click on a unit or an item with right click to get a new tooltip, it means that the timed message with the pop-up will be hidden and overwritten with a new one. So it might happen that, I don't know, I want to display that message for 1 second, but before that second expires, I just click with left mouse button to hide it because I don't care about the message, right? So in this case, we want the timer to stop immediately because we don't care about reaching the timeout spot if we're already hidden the pop-up. So we do popup.hidden.connect, stop the timer, and again, just connect it once to make sure that when this happens, we disconnect from the signal. Hopefully it makes sense, it's not too bad. And that's the only utility function we need to now handle those cases where we want to display a message. I use popup.center to make sure that all of these messages pop up on the center of the screen. I think it's pretty straightforward to do so. So let's just save this tooltip handler with Control S, and let's just see where we need those messages to happen. So press Control Shift F to search in a whole project, and I'll just search for to-do because I remember that I've left in some to-do comments in places where we would like to have a pop-up message shown. Click on Find, and we see we have UnitSpawner.gd. And here it says that in the future, throw a pop-up error message here. Because if we grab the first available area where we want to spawn the unit, it might happen that it's null. And if it's null, there's no available space to add the unit to. Well, we can actually handle this now. So if we get rid of the assert statement and the to-do comment, we can just do, maybe just leave a new empty line here. So if we don't have an area, either the bench or the game area, we can use tooltip handler that show time pop-up, no available space for units, and let's display it for 2 seconds. And also very important, return from this method immediately because we don't want to do the whole spawning bit, right? No units will be spawned, nothing. Okay, so let's save this with Control S and let's try to test this. That might be a bit tricky because how do we test this? Like I need to be very fast with my buys to, if we go back to the arena scene, I need to be very fast with my buys to fill up the whole game screen, right? Well, we can make this easier to test with a couple of things. First of all, if we select the unit combiner and expand it, we have a buffer timer before combining units into higher tier ones, and we can just bump this up from 1 second to 60, right? This gives us time to buy units very fast. And also with the game area selected, we have our arena unit grid and we have our battle unit grid. Now for the arena unit grid, this is where we store our units and we say that we have a 5 times 8 square, right? 2, 4, 6, no, it's a 4 times 7 space where we can store 28 units. So if we just set this X to 1 instead of 4, then we can just only fill the first column and this bench. So in theory, if we run the game now, I start buying units really fast. I have 60 seconds, so I don't have to hurry at all. And I'll still have some money. Okay, let's see what happens. We have this message, and if I click, it disappears faster. But the problem is, what's the problem here? It works because it doesn't spawn units. I have the error message, it disappears on its own after 2 seconds, and I can also make it disappear faster. The problem is, I still spend the money and consume that shop card for the UI, for the units, and empty my pool, despite the fact that I actually don't get those units. Right? So we need a slight refactor here to avoid that problem. Because now, yeah, the unit spawner won't spawn the unit, but still I have no space to add the unit to, and it consumes the gold and the card that we have here. It removes it from the unit pool and all that stuff. Now the question is, how do we actually do this? Where do we need to update things, and what information do we need to make this change? Well, let's see these elements, right? So if we collapse everything for now, we'll change back everything to its normal value. But if we go to UI, we have our shop here, right? So let's click on our open in editor because it's been a while since we've been there. And now we have the shop cards, and this is where we can buy units, and we have this unit card scene, right? Again, if we click on open scene in editor, this is where we handle clicking on the stuff, removing the gold and everything. So if we go ahead and click on the script icon here, we have this onPressed method, which is a pretty good guess that this is where we need to do things, right? So if we already bought that, we return. Otherwise, we do all this stuff, subtracting the gold, showing the empty placeholders, set the cards bought property to true, play the sound effect, yada, yada, yada. This is where we need to perform some sort of check if we can actually click on it. Because if both of those places where we can spawn the unit are full, we don't really want to execute any of this logic, right? Okay, so where can we get that information from? Where does the UnitSpawner get this information from? Because that's where we make the change. We have this get first available area method, right? And that helped us to sort of decide whether we can spawn the unit or not. So if we press and hold Control and click on this, we have these two lines here. Bench.unitGrid is grid full and game area.unitGrid.is grid full. Okay, and both of those are play areas which have unit grids inside them, right? So if we press and hold Control and click on play area, it has a unit grid attached to it. So we need to have access to two unit grids. Both the bench is unit grid and the arenas or areas unit grid. If we have access to those two inside our card here, then we know for sure whether we can buy that unit or not. We don't care how we get that information, but we need to have that information to proceed. In this case, what we can do is we can scroll all the way up and provide an export variable. That's the fastest way to do this, right? So we provide an export variable, let's say under unit stats, and we say that we have an export variable for unit grids as well now. This is kind of a quick and dirty way to do this in a sense, because in this case, we create a dependency between the unit card. So the unit card needs to have access to two unit grids to have this, but I don't think it's that bad for UI. It's a question of where we get this from, right? But yeah, it could be done more elegantly, like using signals, when you just kind of signal that you want to buy a unit and you get back a Boolean from another system to signal back whether you can actually do the buy or not, which might be a bit cleaner, but I don't think it's that bad in this case either. Right, so we have an export variable. We don't really care how we get this. But when we have it and we call that onPressed method, between this safeguard, we can do another one. And the way we do this is this. We check if the grids are full, which means that we have our unit grids export variable set. And since it's an array, arrays have methods like all, any, map, and things like that. In this case, array.all is pretty useful here because it calls a given callable, which is an anonymous function in our case, and returns true only if all elements in the array return true as well. So what we do is we grab the unit grids from the array and return if the grid is full. Now there are 4 cases, right? It might happen that both of those are not full, one of them is full, the other one is full, or both of those are full. This Boolean will only be true if both of those grids are full, and we check with that if. If both of those grids are full, we do an early return from the press, just as we do when it's already bought, and we don't execute any of this logic. And again, show the timed pop-up here, because when we don't emit the unit bought signal, the UnitSpawner spawn unit method won't even be called. So you could say that we already have this pop-up here. Why do we need to make another one? Well, that's why. Because this was called previously because the unit card emitted this signal that the unit was bought. But now it won't emit this signal because we return sooner. So we need to display the same message here with the tooltip handler. Now, if we save this, that's all fine. But if we go back to 2D view, the problem is with the unit card, I can't really assign these unit grids here, right? Because this is just a UI scene. I don't have access to any unit grids. But that's fine because we actually dynamically instantiate these. So if we go back to the shop, you see that we have some example instantiated versions here, but these are all deleted, I believe, inside the shop. So if you take a look at the shop's script, yeah, inside the ready callback, we just delete all of them. So these are just placeholders to kind of display how they would look like, but we dynamically spawn them with the scene spawner component. So what we need to do here is when we actually spawn one, right, when we roll for units, this is where we spawn it. And this is where we would need to inject that dependency, right? We inject the unit stats, we connect to its signal. So we somehow need to here also pass in that dependency that now it has for the unit grids. So we can do something like this. Now, the problem is we don't have any variables called unit grids, right? So we can't actually do this because the shop itself doesn't have access to it. But the cool thing is if we add another export variable with the same sort of idea, right? We'll have an array of unit grids. We can actually fill these with the shop, because the shop is not dynamically instantiated. We just only have one instance of it, and it's inside the arena where we actually have those unit grids. So now if we have this new export variable here, we don't have the error message anymore, and when we spawn a new card, this external dependency will be fulfilled by the shop itself. Now if we save this and go back to the arena where we have a shop instantiated, here I can actually reference those unit grids. In the shops scene I can't. So we have the same problem, right? Like, what do I assign here? We just have a UI node. But the thing is, inside the arena where I use the shop, I can do it. So if I go to unit grids, set the size to 2, assign the first one to the bench, assign the second one to the arena unit grid. Now I have these two dependencies, and these will be sort of injected to all the shop cards. So in theory, if we save everything and run the game one final time, let's just make this a bit smaller, I can start buying units. And if I start buying units, reach the spot where I'm full, I can no longer buy and lose gold on it, you know? I can spam, I can get the same pop-up over and over again, but as long as I don't have space, I can't buy new units. If I sell 1 or 2, it still works, but if I'm full, I can no longer buy any new units. Pretty cool, huh? So that's pretty much all there is to it. Let's not forget to set everything back to normal when we confirm that it works. So if we go back to our unit combiner's buffer timer, let's change it back to 1 second. And also for the arena unit grid, let's make sure I can actually buy those 4x7 units. Awesome. So if we save everything with Control S, I think that concludes the whole series, right? We have everything working. Tooltips, items, item combinations, abilities, trade bonuses. We did everything that I really wanted to do with this project. I'll see you one last time for actually fixing any bugs that were reported by you or discovered by me. So we'll have an extra bug fixing episode, but besides that, that pretty much concludes the AutoBattler. Thank you everyone who came along for this wild ride. I hope you enjoyed it as much as I did, and I'll see you in the next one. Bye-bye.